Hey guys, today we're going to be taking a look at how we can solve integrals in the form of sine x to the power of m or cos x to the power of m. And obviously these are some trig functions, so we are obviously going to need to know our trig identities and our trig formulas concerning sine and cos specifically. And what I mean by that is questions like these, they're going to come like integration of sine to the power of 4x dx. Now, right off the bat, I know I can't apply u substitution, and if you want, you can go ahead and factor it, but I factored this, and I came to a point where I was just going in circles. So I know factorization isn't going to help. So as a result, we need to know some of our trig identities to actually solve these. And let me actually pull them up on the screen right now. All right, so here are the equations I was talking about, the trigonometric equations that are going to be really helpful when you're solving these types of integrals. So let's go through them step by step. So we have sine squared x is equal to 1 minus cos 2x over 2. Similarly, we have cos square x, which is equal to 1 plus cos 2x over 2. So between this one and this one, it's just this sign that's different. Hopefully that won't be too difficult to remember because the next two are a bit more tricky. So let's start with sine 3x. So we have sine 3x is equal to 3 sine x minus 4 sine cubed x. And cos 3x is equal to 4 cos cubed x minus 3 cos x. There isn't a really easy way to remember these. Just remember that sine 3x just has sine for both and cos 3x has cos for both. But other than that, you are going to need to remember which comes first, the cubed or no cubed. And it's just going to come into habit the more practice problems you do. So yeah, these are the four equations that are going to be super helpful in finding the integral of these. Other trigonometric identities, especially like sine 2x is equal to 2 sine x dx. 2 sine x cos x. I'm already getting into integrals. But this identity is also going to be truly important. Essentially, every single trigonometric identity is going to be really helpful because there is no concrete number of steps you need to follow to solve these integrals. It's mainly just simplifying and simplifying until you're ready to integrate something that's not that difficult. So in that case, let's just get right onto the problems. All right, so we have our first problem, integral of sine squared x dx. Right off the bat, I see we have one of our formulas over here that matches with this problem quite closely, and that is the first one. So sine squared x equals 1 minus cos 2x over 2. I'm going to use that. So this integral is going to be equal to integral of 1 minus cos 2x over 2 dx. I'm going to take that 1/2 out of the integral. So 1/2 integral of 1 minus cos 2x. I'm going to expand the integral. So 1/2 integral of 1 dx minus integral of cos 2x dx. And now you could see we can definitely solve this integral. Earlier, we had no idea what to do with that sine squared x, but after simplifying it, it becomes much easier to integrate to the point that we just need our basic trig knowledge and our basic u substitution knowledge. So now we have 1/2 integral of 1 dx is going to be x. Over here, we have to apply u substitution. So I'm going to say let u equal to 2x. And let's take the derivative. So du equals to dx. Dx is equal to 1/2 du. So this is minus 1/2 integration of, not sine, cos u and du. I'm just applying u substitution. If you don't know what u substitution is, I'm going to link that video in one of the corners over here for a full tutorial on u substitution. Carrying on, we have 1/2 x minus the integral of cos u is going to be 1/2 sine u. And now let's close that. But once again, we can't have our answer in terms of u. We have to change it back to x. So let's substitute that 1/2 x minus 1/2 sine 2x plus c. And that is our answer for this problem. So once again, what we did to recap, we couldn't really do anything with the original problem, so we looked over here towards our left, and we found that, okay, we see that sine squared x is equal to 1 minus cos 2x over 2. We replaced it over here, we started simplifying. We took the 1/2 out. We broke the integrand. And eventually we got two integrals that were pretty easy to solve. I mean, we know u substitution, right? So we could easily solve it. And that is how we got our answer. All right, now for our second problem. This time it's going to be a little bit tricky, but I think you can do it. So we have integration of sin² x cos² x dx. And if you want to give this problem a go, I will give you a hint. You're going to apply sin 2x is equal to 2 sin x cos x. So there is your hint if you want to give this problem a go. But for right now, I'm just going to walk through the solution with you. So in this case, I see that we have a sin² x and a cos² x. That looks a lot like this formula here, right? So here's what I'm going to do. I am going to put 2 sin x cos x, and I'm just going to square it. So this is equal to 4 sin² x cos² x, right? When I expand that squared. But obviously we don't have a 4 in the original problem, so I am just going to multiply the whole integrand by 1/4. That way the 1/4 and this 4 cancel out, you're left with 1. Now that we have that established, I see that the thing inside the parentheses is actually equal to 1/4 sin 2x squared dx. Another way you could write this is equal to 1/4 integration of sin squared 2x dx. And that is a lot like this formula once again, except this time it's careful to note, here we have a 2x and here we have an x. So we need to compensate for that. So we have a 2x over here and an x over here. On the right side, we see that this x doubles, right? On the left side, we had just an x. On the right side, it doubled. So on the left side, if we have a 2x, on the right side, it should also double. So we could say 1/4 integration. I'm going to apply this formula once again. We have 1 minus cos 4x over 2 dx. Because as I said before, this doubles to get this. If this was 2x over here, it has to double to get 4x over there. So now that we have simplified that, let's take that 2 at the bottom outside. So we have 1/8 integration of 1 minus cos 4x dx. Once again, it's simply a matter of simplifying and doing u substitution now. So we have 1/8. I'm just going to do this in one go since I'm assuming you all know how to do u substitution. So we have x plus 1/4 sin 4x, and this is supposed to be a minus, excuse me, plus c. And that is our answer. Okay, so for our next problem, we have integration of cos x to the power of 4 dx. So once again, what we're going to do, we're going to apply one of these formulas to our left. And I'm thinking we should apply one of these formulas because on the left side, it does have cos² x, and that's what we're dealing with, except we're dealing with something to the power of 4. So in this case, I'm going to rewrite this as cos² x and to that squared. So this is the exact same thing as this. I just rewrote it so that I can actually apply this formula inside this. So that is integration of 1 plus cos 2x over 2 squared. We can't really integrate it without factoring the squared, so I'm just going to factor the square. Integration of 1 plus cos squared 2x plus 2 cos 2x over 4. Now once again, this 4, I'm going to take it out, so I'm actually going to take it out. So 1/4 integration of 1 plus cos squared 2x plus 2 cos, oh, forgot the dx here, 2x, and then dx. C is that I have a cos squared 2x over there. So I think we should apply this formula again, but once again, remembering that this is x, this is 2x. So just keeping that in mind. So we're going to have 1/4 integration of 1 plus, which is 1 plus cos 4x over 2 plus 2 cos 2x, excuse me, plus 2 cos. Now this seems pretty simple to solve. I think we can simplify this just a little bit. So you know what? I'm just going to take the 1/2 out because I think this 1/2 is kind of annoying me. So I'm going to take that 1/2 out. As a result, that 1/2 will multiply by 1/4, so it's going to be 1/8. Integration of 2 plus 1 plus cos4x plus 4 cos2x dx. Gonna bring this a little bit down. So we have 1/8. I'm going to simplify what's inside. 2 plus 1 is going to be 3. 3 plus cos4x plus 4 cos2x dx. And this is essentially just going to, oh, I forgot that integral sign. It's been a long day, guys. But yes, integral of 3 plus cos4x plus 4 cos2x dx. Now we can just simplify this. So we have 1/8 3x. And once again, just remembering use substitution. So we're going to have plus 1/4 sine 4x. And this is going to be, let's see, plus 2 sine 2x plus c. Can't forget that plus c. And that is our answer. All right, so for our last problem, we have integral of sine cubed x times cos cubed x dx. Once again, I'm going to give you guys a hint to solve this. That is not the correct color I want. So sine 2x is equal to 2 sine x cos x. But I'm going to go over the solution right now. So this is going to be somewhat like the previous problem we solved. And I am going to simplify this to 2 sine x cos x cubed dx. Last time we did a squared, but the reason I'm doing a cubed is because I have a cubed in the problem right now. And I see that this simplifies to 8 sine cubed x cos cubed x. There is no 8 in the original problem, so I'm just going to multiply the whole integrand by 1/8. Simplifying whatever is inside, I know that's equal to sine 2x, so I'm going to say sine 2x cubed dx. Now I'm going to do 1/8. You could rewrite sine 2x cubed as sine cubed 2x dx. We can't use any of these two formulas right over here. And that is because this has a cubed, right? These two formulas don't have a cubed. But what has a cube, or what has a sine cubed specifically, is this formula right over there. This formula has sine cubed right over there. So you see that you kind of have to switch up the formulas around a little bit. So in this case, we have sine cubed 2x. So let's actually rewrite that. We have 1/8 integration of this. I'm actually going to rewrite this. So I'm actually going to do it right over here. So I'm going to solve for 4 sine cubed x equals 3 sine x minus sine 3x. I'm going to divide everything by 4. 3 sine x minus sine 3x over 4. Now I'm going to replace that in here, being mindful of this 2x and this x. So I'm going to rewrite it as 3 sine 2x minus sine 6x over 4 dx. I'm going to simplify this, so we have 1/8. Actually, wait, no, let's take that 4 out. So we have 1/32. Integration of 3 sine 2x. 3 sine 2x minus sine 6x. Once again, you're just going to apply u substitution over here. But for time's sake, I am simply going to solve this. So we're going to have 1/32. And for u substitution, I know this is going to be minus something cos 2x. This is going to be 3/2. This one is going to be plus 1/6 cos 6x. And then finally, we're going to add that plus c. And that is our answer.